Hey guys, so if you wanted more partial fraction examples, this is the video for you. We're going to go through one example of one of our easier ones, and then another example of one of our more difficult ones. All right, so let's take a look at our first problem. Okay, so we are going to be working with 5z minus 11 divided by 2z squared plus z minus 6. All right, so this is one of our more easily factored problems. Most of you could probably factor this guy in your head. I'm going to go about it the long way. So we don't really need to write this if we're just working on some side work here. So to factor this guy, 2z squared, I want to figure out our two values that when we multiply them together, we get a negative 12, but when we add them, we get a 1. So I got negative 12 from taking 2 times negative 6 there. All right, so we're going to figure out what that is. We're going to go ahead and split our middle term. And what we're going to come up with is plus 4z minus 3z. So 4 times negative 3 is in fact negative 12. 4 plus negative 3 is in fact a positive 1. Now we're going to factor using grouping. So the first two terms, I can pull out a common factor of 2z, and I'm left with a z plus 2. And in the last one, if we can factor out a negative, remember we always want to do that, and I can factor out a negative 3, and we're left with z plus 2. So if I didn't pull out that negative, I wouldn't have our common binomial there. So our final factors are 2z minus 3 and z plus 2. So we'll go ahead and rewrite this guy. 5z minus 11 over 2. Nope, we factored it for a reason. 2z minus 3, z plus 2. Okay, so we're all factored. Once we're all factored, we can move on and start writing some partial fractions. So we have a over 2z minus 3 plus b over z plus 2. Very good. Now I wrote this in a very inconvenient way because I'm not going to have space on that left-hand side to multiply by my least common denominator. So if you're working along with me, don't do that. But we're going to make it work. So multiplying both sides by our least common denominator now over here, that's going to be a 2z minus 3 times z plus 2. And same thing, I'm just going to write it underneath for the sake of space. 2z minus 3, z plus 2. So on the left-hand side, we're going to have that cancel out just like we want, and we'll be left with 5z minus 11 equals, and then we got to figure out what cancels out when we do this distribution. So we're going to have a times the 2z minus 3's will cancel. We'll be left with a times z plus 2 plus b times 2z minus 3. Okay, now we're just about ready to use this. Oh, we are ready to use this to solve for a and b. Okay, so to solve for a, that means I want my term with b to be 0. So this guy, what makes that 0? Well, here you might want to do a little bit of solving. So we would have 2z equals 3. So if I set this guy equal to 0, or z equals 3 halves. All right, so yes, we are going to have fractions. Fractions are good. Fractions help us do things. So we want to go ahead and substitute that in. So let's go and do this kind of the long way around since we are working with fractions. So we're going to have 5 times 3 halves minus 11 equals A times 3 halves plus 2. All right, so first kind of suggestion here is just go ahead and put everything on a common denominator of 2, so that way we can work with our fractions a little bit easier. So we're going to have 15 over 2 minus 22 over 2 equals A times 3 halves plus 4 halves. All right, so now that they're all with a common denominator of 2, it's a little bit easier to work with here. Okay, so 15 minus 22, we're going to get negative 7 halves over here equals A times 7 halves. Ooh, well, that's nice, isn't it? Okay, so to continue to solve, I'm just going to multiply both sides by the reciprocal. On the left-hand side, I simply get a negative 1 equals A. So that turned out real nice there. So let's go ahead and do very similar to solve for B, except this time we won't be messing around with many fractions. No fractions, actually. So we're looking at trying to get this term to be 0, so that would tell me that Z would have to equal a negative 2. Okay, so plugging that in is a little bit easier. So we would go ahead and have on the left-hand side a negative 21 equals B times a negative 7, which would tell us that 3 equals B. So that was much nicer, turned out much better. Okay, so once we're all done with that, we can write our final answer. So we would have, I'm just going to go ahead and do it down here, save us a little bit of space, 5z minus 11 divided by 2z squared plus z minus 6, so our original problem equals, when we break it up into fractions, negative 1 over 2z minus 3 plus 3 over z plus 2. All right, and we're done. We have successfully completed our first example. So if this was the one you wanted to see, stop here, go do some more of your worksheet. If you want to see the more complex one where we have a cubic on the bottom, keep watching. We're going to do that right now. So here's our more difficult problem where we have a cubic on the denominator and we have to use our rational root theorem and some synthetic division to help us out a little bit. So factoring this denominator, our rational root theorem tells us that all of our roots are going to be of the form plus or minus the factors of negative 15 or of 15 divided by 1. So we're going to have 15, 3, 5, 1, and then the factors of 1 are just 1. So let's get this out of the way and figure out what these are. So plus or minus 15, plus or minus, I'm going to order these nicer, 5, plus or minus 3, plus or minus 1. All right, and then you want to test and see which one kind of works. So plug them in, which one gives you 0, or you could just go through and quickly do some synthetic division and see which one gives you a remainder of 0. So I know that negative 1 is going to be a factor. So we can always plug that in and check. There are other ones on here that work. Obviously, it doesn't really matter which one you find. So I'm going to be working with negative 1. So that's what I'm going to be doing my synthetic division with. So let's just set this up real quick. All right, so good old synthetic division. We're going to pull down the 1. We're going to multiply by that 0, negative 1, and we're just going to keep adding. All right, so we're just adding again, negative 15 times negative 1, 15. And again, just always double check that you do get a remainder of 0. that's going to confirm that that was in fact a factor, and that you did in fact factor correctly. So we know that the factor we used was where x equals -1, so our binomial would have been x plus 1, right? This tells us x equals -1. And then we're left over with this trinomial, x squared minus 2x minus 15, that we now need to factor. So this would be x plus 1 stays with us, and we would have x minus 5, x plus 3. So now we have all three of our factors, and we can go about continuing this problem. So if at any time I'm working a little bit quick for you, you can pause, rewind, rewatch, whatever part of this. So just keep that in mind. If you need to write something down, pause the video before we move on. Okay, so we have our original rational expression, but now we have factored it very conveniently. X plus 1, x minus 5, and x plus 3, and we want to break this into our partial fractions here. So we're going to have a over our first factor, x plus 1, plus b over our second, x minus 5, plus c over an x plus 3. All right, and we want to multiply by that common denominator in order to be left with only things in the numerator so that we can actually go ahead and solve. So our common denominator is going to be x plus 1 times x minus 5 times x plus 3. All right, and same over here, x plus 1, x minus 5, x plus 3. So over here they just cancel, which is very nice. And then when we distribute, only some things cancel when we distribute on the right-hand side. So our first term is going to turn into a times, let's see, the x plus 1s cancel out. So x minus 5, x plus 3. Then we're going to have b times, this time the x minus 5s cancel out, x plus 1 times x plus 3. And then for c, the x plus 3 cancels out. So x plus 1, x minus 5. All right, once our denominators are gone, this is when we can start solving for a, b, and c. So for a, we want the terms with b and c to cancel out. Their common factor here is going to be this x plus 1. So we want to let x equal a -1 here in order to help us solve. So we're going to end up with a 12 equals a times -12, which will tell us that -1 equals a. So let's go ahead, very similar, let's look for b. So we want the terms with a and c to be 0. They kind of have this x minus 5 in common. So let's let x equal a +5. What happens when we do that? Well, we get -48 equals b times 48, which tells us that -1 equals b. So it's okay for them to be the same number. That might happen. All right, and then C, we want to let A and B go to 0 here. So that's telling us that we want x to equal -3. And we're going to end up with 16 equals C times 16, which tells us that 1 equals C. All right. And then we're just about ready to finish. So we're going to take our original -x² rational expression. So with the non-factored denominator now, because we're writing our final answer. And we're going to write our constants in. So a was -1, that was divided by x plus 1. B was -1. And C was a +1. And we are all done.